This not only works inside of the data center, but any of you gentlemen or ladies that have users that you manage, wiring closets and things of this sort. We have our data center environment, and this trunking system and distribution system works out for your wiring closets as well. And just kind of show you a little bit of the differences between the jumper approach and the trunking approach. Anybody that, we can reduce 70% of their cabling or bulk cabling inside of racks or active machines would be pretty interesting. 200 cables versus 3 trunks. So again, when we build this thing out, we want to do that kind of a system. And again, it can be as full large scale as we want, or we can scale it down to fit your environment. But we want to reduce the cable inventory and obsolescence. Remember, we want to keep in mind, we want to develop a system or put an infrastructure that's going to last us 10 to 15 years. It's going to handle those 2 or 3 generations of data center or data rate increases. We want to procure cables, again, that are upgradable. We want to make sure that once you put that infrastructure in, if they change connector types, it's going to be easy to do for you, okay, as opposed to pulling out cable or laying it back underneath the floor. We want to reduce overall costs, obviously, and this becomes very important. And then our overall goal is zero downtime. Any questions? Yes, sir.
But I don't know a whole lot about fiber and the same coming out. But I'm thinking, being the hardware guy, you're taking a single point fiber, you plug it into your server, you plug it into your switch, whatever. When you have a system like this, now you're adding 4 connections in between that.
Correct.
So what kind of loss do you have with connections? How reliable is that? Is there any degradation with having 4 down connection points as opposed to having 1 single cable?
Good question, and if you give me probably about 10 minutes, I'll get to that. How about that? Okay. But I want to go through here. Is everybody familiar with these connector types up here? Going back in history, this was one of the first generations that some of us have seen. The SCON connector, the first IBM plug-and-play kind of channel built back in the late 80s. Bulletproof style connector, very big. In the networking environment, you probably saw more of an FDDI or RSD connector, which was a retractable or fixed style duplex connector. In your patching environments, in your networking environments, we had our ST connectors, we had our SC connectors. That migrated obviously into the LC duplex. Everybody's seen the LC duplex connector, okay? Which is really the de facto standard for a lot of systems today. Obviously, we all know that. The MTRJ, some of you have worked for it or worked with it in the past. That was kind of the intermediary step between the SCON connector and slow multi-mode technology. That has since kind of been replaced also by the LC connector. You might still see some MTRJ, obviously some legacy product, and then some 62.5 particular type of equipment. The latest generation that we're seeing out there, okay, is an MPO style connector, familiar to a lot of us as an MTP style connector. Everybody who has not seen this connector. This connector actually has been around for quite some time. It's been a de facto standard in the kind of mainframe open system area for quite a while now. Its main benefit is, as you see, is the same size as an LC connector, so it offers the same footprint. The big advantage is it offers you a 6-to-1 plug factor with an LC. So when we start talking about high fiber counts and managing fiber, and bringing a lot of data from point to point, this starts making a heck of a lot of sense. And the reason why a lot of us have only recently seen this is because there used to be a real big line down the middle of the data center. You probably all know this. Used to have open systems in a mainframe, and then used to have networking, okay? And different people handled the different areas. Now, that line is kind of gone, as we all know, because the networking devices now are chugging out data and speed and things of this sort, whether it be your Cisco devices or your SAN devices or whatnot. Mainframes are shrinking, and they open systems are still running SAN still. So people are consolidating, okay? Data centers are consolidating. More and more people coming up on the networking side of things are now running these high fiber counts. And the machine densities are beginning to be challenging to work with. Important, if you're not familiar with the MTP style connector in a pass-through style trunking environment, get familiar with it, because now at the 10 gigabit spec, and what's next, and we'll talk about this 40 gigabit and also 100 gigabit, you're going to have specs for parallel optics. A lot of you have probably seen a lot of the IBM blade centers now that use parallel optics. This is actually an active style connector now that plugs directly into the machines. Right? Just like we would an LC connector. Okay? The reason being is, going back here, as As opposed to using a serial type connection, when you plug an LC into a device, you get a transmit and a receive, you get an A and B back and forth. With parallel optics, what you're doing is you're transmitting down 12 fibers at a slower speed, but you're still carrying a heck of a lot of data. It's like getting 1.5 or 2 gigabits over 12 individual fibers as opposed to trying to get 10 gigabit over 1 fiber. And then you get transmit back in the opposite direction. So, because of these high-density connectors, we have developed the cabling that goes along with it. Okay? This is the latest generation trunking cable. What I'm holding in my hand right now is a 72-fiber connector, 72-fiber trunk cable. All standard product, and there's a new bend-infused fiber. If anybody has worked with trunk cables before in the past, Rob, okay, you know that this is 2/3 less size than what's usually standard out there, even today out there in the industry. And the bend radius is 10 times full. When I tell you that 1,000-foot trunks of this you can pick up with one hand, it's incredible. Okay, it's very easy to work with. As you see here, this is how many legs I have on a 72-fiber connector or a 72-fiber trunk cable using an connector. But I also talk about reducing costs for everybody. Take a look at these factors here. It's about 1/5 the weight of your standard trunk cable that's out there. So especially in our energy crunch today, all right, just shipping costs alone will save you a heck of a lot of money. And ease of installation. Okay? And how do we distribute all this? Well, we go through a various stage of everywhere from 1U all the way up to some monster 9Us. We'll show you those as well as 0Us using this type of technology. So, how this technology works for you guys that stop by the booth. It's very simple. This connector makes it, again, it takes the questions or expertise out of the fiber field so you can take control over your own networks or data centers. It's a keyed solution, okay, so you can't plug it in wrong. Right? And it also has a white dot that you match up on the adapters on the back side. And when I tell you that it's a 3-second plug-in for 24 fibers, right? That's all it takes. Okay, sit around, you guys can play with that. Internal to that, the set module, we do all the discrete fan-outs for you. So just happen to be one of the set module that we do custom. But internal here is where we do all the discrete fan-outs. We put a cover over it, factory seal, we go in the box. Okay, but again, this is all the discrete fan-outs. So it's a 2-second plug-in. And again, they come in various different flavors. And what that does for us is it lets us handle that density that's required. Take a look at our first solution here for the enclosures. We have a 1U fixed port, which is the highest dense 1U on the market right now, that house 48 ports and 96 fiber. Now, take a look at the size of this box here. If we were working with 96 fiber, doing it discreetly, with regular cables, I think it'd be very easy to work inside of this package. With the MTP solution, again, 4 plugins on one side, 4 plugins on the other, and a total of about 15 seconds, and we have 96 fiber interconnects. Okay? And again, we put it in the top of the rack with our server equipment, or whatever equipment might be in there, and then we manage all that connectivity inside of the rack. You can see here on the side the new trunk style cables. This being a 48 fiber, okay, you can see the 72 fiber in the back end. And how they load across. This is how much space it takes up in the back of the enclosure. Very easy to work with. You don't want a fixed port if you want to expand over time like we talked about. We have cassette module versions as well, so you can build out and add cassette modules as you proceed forward. They come in at 4U, 6U, and then some monster 9Us. Anybody have some big end directors in their data centers?